this video is part 3 of a set of videos on function notation, evaluating functions, and solving functions. So in this video we're going to talk about how to evaluate and solve functions when you are given a formula for that function. In the previous videos we were just given tables and graphs. So in this problem we're given h of x is negative x squared plus x. And we're asked first to evaluate some functions. And in the previous videos we learned that the number that's given inside of the parentheses, this 2 right here, is an x value. And basically whenever we're given that number, we're just going to replace that wherever we see the x. You need to be a little bit careful when there are exponents involved or negatives involved, that when you are substituting your value, you are putting that in parentheses so that the exponent applies to it properly. So in this particular case, if I'm asked to find h of 2, I'm asked to figure out what the y value is when x equals 2. That's negative parentheses 2 squared plus 2. This would be negative 4 plus 2, or 2. So we would write h of 2 equals 2. In part B we do the same thing. We need to be extra careful with this negative here. H of negative 3 is going to be negative parentheses negative 3 squared plus negative 3. Now when I evaluate that, this exponent applies to the base of negative 3, but not to that negative out in front. So the negative out in front stays. Negative 3 times negative 3 is 9, plus negative 3, and negative 9 plus negative 3 is negative 12. So I would say h of negative 3 equals negative 12. And just to review what that means in terms of points on the graph or points in a table is that in this case the point 2, 2 is on the graph. And over here in part B it means the point negative 3, negative 12 would be on the graph of this function h if we were to have a graph. Now the other thing that you can do, you can plug in numbers for x. You can also change the variable, and the process stays exactly the same. If you want to find h of a, all that's asking you to do is plug in an a wherever there was an x before. So h of a would be negative a squared plus a. And if there were something I could do with that algebraically, like combine like terms or simplify it, then I would. But in this particular case there aren't any like terms, so I'm just done. When I get bored with English letters, maybe I'll move to Greek letters. It's the exact same thing. I'm trying to emphasize here that you don't need to worry about what the symbol is. You just need to understand the process. So this might look like a triangle to you. I meant it to be a Greek letter delta. This says h of delta. Well, that would just be negative delta squared plus delta, just like we did with the 2 and the negative 3 and the a. Now we can do with any symbol we want. We could even do it with a letter when we're starting to feel kind of crazy. H of crazy would be negative crazy squared. I don't even know what that is, but it's okay. Plus crazy, and again, if I could do something with that algebraically, I would. In this particular case, I can't. Now f is when you actually can do something with it algebraically. So just like I substituted the word crazy over here, when I have a whole algebraic expression like p plus 4, I'm going to substitute that in where the x was, and I'm going to be careful to put it in parentheses. So h of p plus 4 is going to be negative parentheses p plus 4 squared plus p plus 4. Now in this particular case, because these are now algebraic expressions instead of just strange symbols, I can actually expand this and simplify. So you want to remember, I guess I'll put it over here on the side, that p plus 4 squared means p plus 4 times p plus 4. And you need to do FOIL on that. And when you do, you're going to get negative p squared plus 8p plus 16, and then I have plus p plus 4. And if I distribute this negative and combine my like terms over here, I'm going to get negative p squared minus 7p minus 12. So that's the simplified version of it. Again, you need to distribute and combine your like terms, but that's what you should end up with. Now in A, B, C, D, E, and F, we were given the input, whether that input was a number, an English letter, a Greek letter, a word, or a whole algebraic expression. Every single time I was given what was in the parentheses and I put that in where the X was. In G and H, I'm given not only something to put in where X is, but now I'm told what that's equal to. So I'm actually being told a Y value. So in this particular problem, it says solve h of a equals 0. There's two things I need to do here. First, I need to plug in the a where the x was. So that's negative a squared plus a. And I need to make that equal to 0. And when I'm asked to solve, that means tell me what a is actually equal to make this output of 0 happen. So I need to solve this using the techniques that we've already learned. I think I can factor this since it's equal to 0. I'm going to factor out a negative a, which will leave me with an a minus 1. And that means that either negative a equals 0 or a minus 1 equals 0. That's going to give me two solutions. This first one is going to give me a solution of 0, and this second one is going to give me a solution of 1. I do the same thing here in H. H of c equals negative 6. So this part right here says put a c in where the x was. So that's negative c squared plus c. And I'm also told that that's equal to negative 6. So I'm going to make that equal to negative 6. And now I need to solve this equation. This has an exponent. The technique that we've just learned is factoring. In order to use factoring, I need to make it equal to 0. So because I don't really like this negative coefficient here, I'm going to actually move my terms over to the right side. If I do that, I'm going to get positive c squared minus c minus 6. And if I solve that, let's see, this is a trinomial. I need a product of negative 6 and a sum of negative 1. I think that's going to be c minus 3 times c plus 2. So I have two solutions. This factor is going to give me a solution of 3, and this factor is going to give me a solution of negative 2. And that's a little bit about evaluating and solving functions when you're given the formula.